So on the 8-6 worksheet, question 6, parts A through D, I'm glad I had a couple of people ask about this. These are relevant, these actual series, and some very like them, can pop up in a probability course. So when you're taking a later course and you say, I've never seen that before, you'll be lying. And hopefully you'll say, oh yeah, I did see that and I've forgotten it, but now you'll know where to go back and look more specifically. So if we ask, what is the function that's represented by the series n x to the n, part A? What is that function? What function does that represent? We've got to start with these series that we know. For instance, what does it remind you of? Well, it reminds me of 1 over 1 minus x, which is the series x to the n. They both have that x to the n term. Now think of what we've done with our series. We've substituted, replacing our x term all that we want. We have taken derivatives and integrals. Okay? Looking at this series on the right side from n equals 0 to infinity, I can't substitute to get an n because we're only replacing x's. So the only way I can think of to get an n down in front is to take the derivative. So let's do that for a step. So here I'm going to take the derivative of both sides of the equation. When I take the derivative of the left side, I'll get 1 over 1 minus x squared. I get a negative 1 from its power, and from the chain rule I get another negative 1, so that becomes a positive 1. On the right side, when I take the derivative, that's the series from n equals 0 to infinity of n x to the n minus 1. Now if you notice, if you actually plugged in, a side note, if you plugged in n equals 0, you're going to have 0 x to the negative 1 plus 1 x to the 0 plus 2 x to the 1, and so on. So this first term doesn't matter at all. That's why when the book takes derivatives, it's going to throw off that first n, because it's always going to be a 0 times something, so it just didn't matter. Okay? So we'll throw it off also. Now, this looks closer to our desired series, nx to the n. All it's missing is an extra x. So in this next line, I'm just going to multiply by an x, both sides of my equation. So the left side is now x over 1 minus x squared equals the sum, n equals 1 to infinity. I could put the x out front if you want to, if it makes you feel better. I'm multiplying the series by an x, nx to the n minus 1. But when I simplify the right side, that's the series nx to the n from n equals 1 to infinity. And that's exactly the series we asked about. So this series represents this function for part A. For part B, we ask, what is the series n over 2 to the n? Well, normally I wouldn't think of this, but since we just saw an example that involves n and then a variable to the n, I think, oh, that variable could be a fraction. That would get my 2 in the bottom. So this is probably the series n times 1/2 to the n. And I see that that works out pretty well. So this series on the right hand side of this equality can be modeled by the function that we have a square around from part A. So this is equal to x, where x is a 1/2, over 1 minus a 1/2 squared, quantity squared. So that's 1/2. 1 minus 1/2 is 1/2. You square it and you get 1/4. So 1/2 divided by 1/4 is 1/2 times 4, which is 2. So we now know that if you add up 1 over 2 plus 2 over 4 plus 3 over 8 plus 4 over 16 and so on, you're going to get exactly 2. So that's the answer to part B. You can probably guess how we're going to do C and D now. We'll go ahead and do it anyway. So C, I want to know about the series, want the function for the series n times n minus 1 x to the n. So I gave it to you in the nice way, the way that kind of spills the beans. You see an n and you see an n minus 1. Well, that n minus 1 probably appeared from a derivative. If I was tricky, I would have made it look like part D without ever showing you C, and you would have said n squared minus n, and you hopefully would factor it. So we want the series n times n minus 1 times x to the n. You're going to say what we have is that x, we have that x over 1 minus x quantity squared is the sum of n x to the n from n That was not the one I meant to write. I looked at my notes wrong, so I apologize. So, in order to get this n minus 1, we're going to take the derivative twice. My notes say to start here, 1 over 1 minus x, and the sum x to the n. If you take the derivative once, you're going to get 1 over 1 minus x quantity squared equals the sum n x to the n minus 1. We're motivated because we want to see an n minus 1 in the denominator, so this version that I had is going to be useless to us. So we want to bring this down by taking the derivative again. Let's be careful with our limits. We start with n equals 1 now, and we go to infinity because the first term disappears. When we take the derivative, we're going to get a negative 2 over 1 minus x quantity cubed times another negative from the chain rule, so positive 2 over this. So that'll equal the series from n equals 2 to infinity, n times n minus 1 times x to the n minus 2. So far I've just used the chain rule. I'm not trying to get anywhere with my exponents here, x to the n minus 2. But I notice that's not what I want. I want an x to the n. So all I need to do is multiply by an x squared. So in this step I'm going to multiply by x squared, which gives me 2x squared over 1 minus x quantity cubed equals the sum from n equals 2 to infinity, n times n minus 1 times x to the n minus 2 plus 2, which is just an x to the n. And that's exactly what we asked about. So anytime I see this series, or anytime I see this series with something plugged in for x, I can replace it with this function. So that's it for part C. For part D, we ask, what is the series from n equals 2 to infinity, n squared minus n over 2 to the n? Well, n squared minus n is just these two terms distributed. So this is equal to, you could write it as the sum from n equals 2 to infinity of n minus 1, 1/2 to the n. And from our equality right here, we know that that's equal to 2 times x, which is 1/2, squared, over 1 minus x, which is 1/2, quantity cubed. So, doing a little arithmetic, we get 2 times 1/4 over 1 minus 1/2 is 1/2, cubed is 1/8. So 2 over 1/4 is 1/2 times 8, which is 4. So that's it for 8.6. This is the kind of thing that can appear later, but notice, in both instances we started with geometric series. We started with the geometric series and we manipulated it to get what we wanted.